Okay, so this lecture is a continuation of our previous notebook, where we will train a model to predict whether tomorrow's return will be positive or negative. Previously, we used linear regression, which is a model that predicts a real value target. However, you may have noticed that we never actually use the value of the model predictions, only the sign. So you may recognize this as a classification problem. In this lecture, we will train a classifier directly and see how well it performs. We'll use a model called logistic regression, which is another linear model. You can think of it like a classification analog of linear regression. Okay, so we'll start by importing logistic regression from scikit-learn. Next, we'll create an instance of our model. Notice that I'm passing in one argument into the constructor called C. C controls what is called the regularization penalty. Basically, it's a way to prevent the weights from becoming too large, which can be problematic. Again, this is a more advanced technique that you could learn about if you learned logistic regression in depth. Okay, so next, we need to convert our targets into binary format. Currently, they are just real numbers. We can do so by assigning the Boolean array y greater than 0. We do this for both the train and test set to get ctrain and ctest. So for our classification models, we'll use x and c instead of x and y. Luckily, the API for scikit-learn models is pretty much the same, no matter what model you use. So again, we call model.fit on xtrain and ctrain, and model.score on both the train set and test set. So let's run this. Okay, and we see that our model does slightly better than chance for both the train and test set. Next, we obtain our predictions by calling model.predict on both xtrain and xtest to get ptrain and ptest. Now, in case you're curious, we can cast these to a set to check what the possible values of ptrain and ptest actually are. So since we passed in booleans for the target, we get back booleans for the predictions. Next, we're going to compute the return of our algorithm when we use this new model. Basically, this is just a copy of the code we had earlier, where we assign ptrain and ptest to the position column. Then we multiply the position column by the return column to get our algorithm's return. Next, we're going to compute the sum of the algo return column for the train set. Okay, so we get about 0.59. Next, we're going to check the sum of the algo return column for the test set. And we get about 20%. Next, let's again print out the buy and hold performance so that we can compare. Alright, so we see that our classifier results in a slightly better performance than buy and hold.